Okay, so that's chapter 1. Pretty low-level definition. So in chapter 2, we're going to talk about methods for describing data. We're going to start with numerical measures of central tendency. So has everybody heard of the central limit theorem?
Say again.
Central limit theorem? All right, we'll talk a little bit about that in a second. All right, so let's do a kind of thoughts on this. So there's a strike with employees over wages. So there's 11 total employees, right? And their total salaries are, I think, 770,000 combined. So the mode of this set is 20,000. So what is the mode?
I think it's motor intentional.
No,
That's like the other one.
that's a different. We're gonna come to that one.
What's the most common number?
The most common number, right? So most people at this company make only 20,000, and that's what the union is saying. The median is 30,000, while the mean is 70,000, which is the president's argument, saying on average everybody makes 70,000. So different measures are used. So who's right?
I mean, mathematically, they all are.
Right. So,
It depends on what you're trying to actually measure.
or what perspective you're trying to take.
Right.
But talk about tests in the future. See if we can rationalize the argument. So there's the central tendency of the set of measurements. That is the tendency of that data to cluster around the center about certain numerical values. So measures of central tendency. And then on the other side, we have measures of variability or dispersion about some particular central tendency.
Don't forget,
Yeah.
get this PowerPoint presentation later.
Oh yeah, I can upload it. I just made it, I think yesterday. So. Yeah, so the variability about a set of, so it's how dispersed the data are. So in statistics, we have samples and populations, right? So you'll see the sample as either X bar or Y bar, it could be either one. And mu, the Greek letter mu, is for the population mean. So sample mean, population mean. For sample size, we use lowercase n for sample, and the total population is uppercase n. Just some notation. So I assume everybody knows how to calculate mean. So it's the most common measure of central tendency, probably the average, the mean, the one you hear the most about. Kind of acts as a balance point or the middle of that data, right? It can be affected by extreme values called outliers, and then to calculate it out, this, has everybody seen this sign before? Summation. So it just means that we're going to sum each of the values from our sample and then divide by the number in that sample. So that's just an example. We take these 6 sets, we sum them together and divide by 6, so our average or mean is 8.3. Median is also a measure of central tendency. So it is the middle value in an ordered sequence. So n is odd, then the middle value of the sequence, and if it's even, we have to average the 2 middle values to get the median. So the advantage of the median is it's not affected by extreme values. So if we go back up to our example, the median might be more useful because there's a lot of extreme values, right? The CEO makes 400,000, and that's significantly different than the rest of the. All right, so the mode, another measure of central tendency, and it's just the most common value. And you can have something called bimodal data, which means there's 2 modes, and multimodal data. It can be used in both quantitative and qualitative data. So So we have no mode if we have all unique numbers. We have one mode, or we have 3 4.9s, or we can be bimodal, where we have 28 and 43 as both modes. So we're interested in the shape of a distribution, right? Has anybody heard of the normal distribution? The bell-shaped curve? So that's the normal distribution. So this would be a symmetric distribution, where the mean and the median are equal in a normal distribution. Left skewed is when the mean is below the median, and right skewed is when the mean is above the median. Okay, we don't talk about kurtosis. There's another. There's 4 moments in statistics that we're really interested in: the mean, median, skew, and kurtosis. So the skewness tells us which way the data is leaning, and then kurtosis is kind of the fatness in the tail. So how thick is this tail? But I think we talk about it either soon or later. So those are all measures of central tendency. We also have measures of variability. We have the range, which I'm sure you've heard of, measure of dispersion, where we order the numbers, we take the largest and we subtract the smallest, and it ignores how the data is distributed. More importantly are the variance and standard deviation. Have you guys heard of variance and standard deviation? I know in healthcare we use standard deviation a lot because when we're doing quality controls on our tests, in order for the test to be reported out, our controls have to be within 2 standard deviations. So these are both measures of dispersion. They're the most commonly used. So it takes into account how the data is distributed. So standard deviation is represented by S for the sample and sigma for the population. For variance, it's S squared. It's very important to remember this relationship, that the standard deviation squared gives you the variance, and vice versa. If we take the square root of the variance, it'll give us the standard deviation. Sigma squared is also the variance. Sample size stays the same. So outliers are observations that are unusually large or small relative to our other values, and they can cause us to skew some of our results. So outliers are typically attributed to one of the following causes. It's a measurement is observed, recorded, or entered into the computer incorrectly, or the measurement comes from a different population, or the measurement is correct but represents a rare chance event. Yeah. All right, so we also have measures of non-central tendency. We have the interquartile range. So we have our lower quartile, which is our lower 25%, and our upper quartile, which is the 75% above, and we have the middle quartile. Box plots. Does anybody actually use box plots? Like I always see this slide. I'm like, I don't know that I've ever actually used this in a meeting, but it's a visualization that can show you the interquartile range, the median. Usually you can see some dots on the side for outliers, and it'll put the mean in there. But it's not something I routinely use in presentations to CEOs or anything. So I won't go too in depth on that. So describing qualitative data, some key terms. A class is one of the categories into which qualitative data can be classified. So the class frequency is the number of observations in the data set falling into a particular class. Relative frequency is the class frequency divided by the total number of observations in the data set, and the percentage is that class frequency multiplied by 100. So data can be presented in different ways. For qualitative, we can do summary table or frequency table. So it can be a bar graph, pie chart, Pareto diagram. We'll talk about what each of those are. Quantitative data, you can do dot plot, stem and leaf, histogram. We don't generally use those, but histograms are useful. So summary table lists categories and numbers of elements and categories obtained by tallying responses in a category. Does anybody use pivot tables? It kind of looks like a pivot table to me, but that's how we can pull that together.
We are told that we're going to use a lot of tables.
Yeah, used it some in my class, but I think there's another class, another tech DSIM class that you'll probably use it a lot. Focus, yeah. So bar graphs they show the categories of classes of qualitative variables are represented by a bar. I think pretty common. Pie charts, categories of classes are put into a circle. Size of each slice is proportional to the relative frequency. A Pareto diagram is a bar graph with the category classes of the qualitative variables arranged by height in descending order. So, bar graph, it's not a Pareto because they're not in descending order. Pie chart shows the breakdown of total by percentage of the circle. Pareto is just a bar chart that's descending. Graphical methods for describing quantitative data. So histogram, possible numerical values of the quantitative variables are partitioned into class intervals, where each interval has the same width. These intervals form the scale of the horizontal axis, and horizontal bar is placed over each class interval. So we have two quantitative axes for a histogram, which is what kind of makes it different from a bar chart. So these are the formulas to calculate out the measures of dispersion. I think it should have been further up, but I'll show you how to do these in Excel so that you don't have to calculate them out by hand. So what I said a second ago about in up here we have different standard deviations. So within one standard deviation, we account for 68% of the data. Within two standard deviations, we have 95% of the measurements. So basically, the idea of quality control was if you're within two standard deviations, that results 95%, probably right. And then three standard deviations, 99.7, super accurate. All right, before we get into probability, I'm going to check. Homework and quiz. I don't think they're averaged. I think it's the highest. So pull this up. Put in some random data here. So if you've used Excel before, this should be pretty easy, but if you want to get the average of a set of data or the mean, it uses the average function. Highlight it, give you the average. The median is the median function. Same idea. Variance, I get the older version. Get the variance, that way you don't have to calculate it out. But the easiest thing to do is to go to the data tab. Let's see. Yeah, I was gonna say. Gotta add in. There we go. All right, so data analysis, and we can get our descriptive statistics. We can highlight all of our numbers, get our summary statistics. And it'll calculate all of our summary statistics for us.